This Lathe Assembly project involved a series of steps including setting up machines, executing precise machining operations, and assembling the parts. This process requires careful coordinations and effective time management to ensure the student meets project deadlines, follows safety protocols, and produce parts that meet the quality standards outlined in the project specifications. However, there are several challenges faced by both students and lecturers. These challenges include inefficient scheduling of machine usage, limited availability of equipment and tools, and it requires students to share the resources available, and difficulties in tracking students' progress and performance, as the workshop is often shared among different cohorts of students as well. Coordinating machine usage becomes a logistical issue. Additionally, without proper management of workflow, students may face delays, resulting in frustrations or incomplete projects. Hence, these simulation models for the manufacturing process of the Lathe Assembly project is to simulate and estimate the total production time for the production of Lathe Assembly project for a streamlined workflow management in order for teaching purpose. I will show the demonstrations of the simulations model that we developed using 3 different value factors of process that can give impact of production time of the Lathe Assembly project. We will be choosing 3 different factors that will have significant impact of the total operation times. The first one is the measuring and marking. The second one is taper turning operations, and the third one is profile turning operations. This Lathe Assembly project consists of 2 parts, Part A and Part B, and the assembly parts of both parts. Both raw material of Part A and Part B will be inserted through raw material A and raw material B here, and then both of raw material will go through series of operations processes to finally be disposed or as a finished product. So we will choose 3 factors that give significant impact to the total operations process. The first factor will be measuring and marking operations time. The second factor will be taper boring operations, and the third factor will be profile turning operations. I will now show the demonstration of the simulations model that we developed using 3 different value factors of process that can give impact of production time of the Lathe Assembly project. The first value will be the maximum operation time of each factor, which is 30 minutes, 32 minutes, and 35 minutes. The second value will be the minimum operation times of each factor, which is 10 minutes, 12 minutes, and 15 minutes. And the third one is the average operation time of each factor, which is 20 minutes, 22 minutes, and 25 minutes. So I will show here, I will change for the maximum time, 30 minutes here for factor 1, 32 minutes for factor 2, and 35 minutes for factor 3. And then I'll run the simulations for 50 replications. And the result shown for the total time is 1,359 minutes for the changes of maximum time. And then I'll change to minimum time. 10 minutes for factor 1, 12 minutes for factor 2, and 15 minutes for factor 3. So the result for the minimum operation time shown as 887 minutes of total production times. And for the third value is average time, which is 20 minutes for factor 1, 22 minutes for factor 2, and 25 minutes for factor 3. And then I'll run the simulations. Result shown as 1,183 minutes for the value of average time. In this analysis, we explore the effect of various production factors on overall production times in a manufacturing setup. Specifically, we examine how marking and measuring time, taper turning operation times, and profile turning operation time interact to influence the efficiency of the production process of this lathe assembly project. This analysis stresses the importance of ongoing data collections and regular review of process factors. By continuously monitoring and adjusting factors like profile turning time and taper turning time, production teams can stay ahead of inefficiencies and make incremental improvement. Thank you.